Hi, I'm Tom and I talk about code. Welcome to another Rust programming live stream. Today, more work on a binary format and getting a binary format working for this language, which is going to be really exciting. It's going to let us do a lot of cool stuff. It's going to make it a lot easier to communicate debug information to an instance of the virtual machine running. That's going to save us a lot of headaches. I'm going to be able to cut some really weird edges out of my code. It's going to be a lot better. So we're slowly moving forward. It's also going to mean we support strings in a much more sensible way. The step today is to get our compiler to actually output this binary format, and then depending on how we're going for time, I'll try and add debug symbols to this binary as well, because we've left a bit of space in the header where we have room to define new things. So I was also just kind of pointing out some stuff I did last stream. This is why having a binary format's cool. We have a load binary format that gets exported in our WASM build now, and when you do that, it sets the entry point based on the binary file. You don't need to guess anymore based on other weird stuff. Have I tried Idris 2 yet? No. I would love to do some Idris streams. That would be really fun. I don't know if my brain's big enough for Idris, but I would love to try it out. Is Idris 2 new? Like, when did Idris 2 come out? Infinite Coder, hello, welcome. Thank you for the shout out the other day. I saw that in my log. Awesome. Couple of people coming in ready for some Rust. So I hope everyone is ready for some very exciting Rust action. Let me just double check that I changed this, because I think I did, right? I think I made this binary, yeah. So when we run our VM, it tries to load from an actual binary file rather than just dumping an arbitrary blob into memory and assuming their instructions. That's good. That's really, really good. So if we go into our lang, if we go into our compiler, CodeGen compile, sorry, here, top level compile. This function, we found it in the end. So this function returns a context with all the functions generated. Okay, so we need to go into our compiler binary, bin lang, the actual binary that builds the final thing. Now, it looks like we've got a bit of old stuff here. Loaded program offset, we can probably get rid of that, right? Maybe this has some special meaning. We're gonna have to pick through some stuff in here. A few years ago, Idris 2 adds multiplicities, which are really great. Erasure with linearity. I don't know. This is why I think my brain's not big enough for Idris 2. I don't know what this means. I kind of know what a linear type is, but I don't know much about. I don't understand combining erasure and linearity. But it sounds interesting. That would be really fun to bash my head against live. So let's go into this top level compile. It takes an offset. Where is this offset used? Context new takes an offset. But why does context new take an offset? Context new, global base. Global base. Where's global base used? Define global, static head, global base plus offset. Offset is static head. So we have this weird, global base, yeah, no, that's okay. Static head moves up, global base. So global base is where the globals start. And this is probably something that I don't know if we need to pass it in. Let's keep doing this for now because it's easier to not change it, but I think this is something I'm going to have to flag in my brain. This is something that probably will be a problem later. Okay, so this output format, annotated ASM, it's not very useful, but we're going to ignore it and plow forward, and we want here to, instead of just putting all of our instructions into a big buffer, we want to actually build a binary. Now, how do we build a binary? Let's look at the VM bin. Not the VM bin. The assembler bin. Not ASM0, that one's still dumb. But this one outputs a binary file. Yeah, excellent. So we just need to build a binary file, set an entry point, set a version, push program bytes. We'll have to be a bit smarter about the entry point, but that's okay. And we can do that. Offset is header size. Yeah, this is fun. Sections, offset in the file is that. Yeah, cool. So we're going to have to be smart. But we've got all this information in the context. So when we call compile, the result of the compilation is a context that has all this information in it. Has everything. So static offset is something we probably want. The static offset is the offset in memory for the static data. So we need to tell, that's going to be part of our header for our binary. We get all of the instructions. Now we'll call this program We'll call this program bytes. We'll call this code bytes, actually. These are the bytes of the code. We don't include static data here. What we do instead is for index I in instructions, we're gonna have a little bit of duplication here just while I type this out a second time. It's worth typing out a second time because it's gonna be just different enough. So we're gonna roll with this. The offset, now we don't care about offset here. We just want to put all of our code into an array, into a vec of bytes. And once we have that, we rely on building a binary file based on headers. The binary file will work out where to put everything. This code we wrote that specifies a binary format will work out how to put this stuff together. So we want to have a couple of vecs of U8 and tell it how to assemble them into something. That's the goal. That's the goal. So I did this smarter, didn't I? I did something else here instead of this mask. I did instruction encode program bytes. Where's program bytes? Program bytes resolved, instruction from stir, instruction raw instruction, instruction encode U16, extend from slice. Yeah, this is what I want. I want to do this. I want to do this because this is a lot better. We'll call this code bytes extend from slice. So this means that I can take a raw instruction, convert it to an array of length 2 of U8s, and so I don't have to do that mask and stuff myself, which is great. That's a really nice simplification. Do I actually need an index? No. This offset's no longer relevant, right? Because this is going to be taken care of by the binary format, so we get rid of this. We don't need to enumerate anymore. I've written it out twice and that's confusing. Let's just get rid of that. So for each instruction, we get it as a raw, we get its U16 encoding, and then we dump it into the big vec8. This static data, we don't put it anywhere quite yet anymore. I'm going to come down, I'm going to copy this from the other file because that's easier. I think that's really good. Cool. So we make a new binary file. The entry point is going to be the entry point of the context. I think the context keeps track of this, maybe? No? Okay, we need to work out res.something. We can work it out from the binary file. The issue with dependent type, back to Idris 2 quickly here. The issue with dependent types is it's hard to know what is erased on compilation. Anything erased used 0 times at runtime, a linear type is used 1 time, 0, 1, unbounded. Variable x is supposed to be used 0 times, passed into a function. If f is used 0 times and x is used unbounded times. Okay. Yeah, that's so... This is still a bit too big brain for me. I think I just need to do it a bit more. Dependent types, I don't know. It sounds cool. Bobius, hello, welcome. Welcome. I'm going to get very distracted, but Idris is on my radar. It would be fun to do. I think it would be really cool. I don't know what I'd do with it, but it would be cool. Cool. So we're just dumping some random stuff in the version. We should probably say this is version like 1. Maybe that's a better version to use. Now, we're only going to have one section here. This section is going to have all of our code bytes. It's going to be read-write. It's going to go at address something, whatever, depending on this thing. Actually, yeah, it's gonna start exactly at this thing because the first byte is the entry point of the program, and it's gonna live at offset. Why is it offset 1? What the hell? That doesn't feel right. Why? Oh, right. We just put something in file offset because we just need some. We just want to put something that won't not be default. Explicit and non-UB friendly. That sounds good. That sounds like what you need when you're doing this stuff, because you don't want to be fighting usability and trying to work out category theory, dependent type stuff. It's pretty complicated. Rust types are affine types. I have heard that. I don't fully understand the implications of this, but I have heard this. I have heard about proposals to make Rust types linear, but again, or like proposals to support linear types, but again, I'm not fully across the implications of this. So we get the header size, that's good. So the header, we're saying our code goes straight after the header, and that's okay. That's okay. Is that okay? See, we're still assuming before we build this binary file that we're putting everything... So what I need to be able to say really, what I really need to be able to say... Actually, yeah, no, sorry, file offset. So we're saying that this goes after... this section goes after the header in the file, which is correct. Data is program bytes. Oh, sorry, we need it in here. We need this in here as well. We actually do... This is more than just the code bytes. This is all the static data as well. Unless we say extend code bytes, and then we want to say bin.data.extend static data, right? Because what does get static give back? It gives a vec-u8. Yeah, cool. So we should be able to extend this with both of these vectors and put it all in one big dumb lump. Then we're going to need another section, right? We'll need a second section. We need to push this section in. Section... it's going to be all of our static data. It's going to be mode 0 as well. We need to work out what these addresses are. We'll say file offset 1 again, because it's just a placeholder value. We're going to do the same thing for the file offset, where we're going to work out... it's going to be this... It's going to be header size plus code bytes len, right? So it's going to be wherever the header... So the header comes first, section 1 comes after the header in the file, and then section 2 comes after the header and then the next section in the file. And the size is code bytes.len, which is great. Oh my god, affine types use 0 1 times. Yeah, exactly 1. Affine types are how Rust does borrow checking. That actually makes sense. That makes a lot of sense. Linear, there's a related concept called affine. Linear with some, control types always different. Affine relationship is linear with less of a fixed mathematical relationship, more that of a crazy stalker. Yeah, there's just less structure, right? It's like a less structure. Is structure the right word? It's like a set to a group, you know. Weakening thing, one of the character. Yeah. I'm not going to read this now, but I have kind of looked into this stuff before. It would be cool to do a bit of Idris. It would be fun to write a language that used some of this stuff more. That would be fun to do one day, but that's a whole other kettle of fish. Oh, hold on. This is actually good. This is good. Affine you can discard but not duplicate. Linearity prevents discarding. Yeah. So, yeah. That's really cool. I've seen some interesting things about like how it's useful for like file IO, but yeah, most of the time I don't see what problem it would solve for me. All right, cool. So we put all that stuff here. We just need to work out where these actually get mapped into the running virtual machine. So what's our entry point? Well, our entry point, like these are going to be the same thing, whatever this is. So let's maybe say get entry point. Can we do this? Res get entry point. And then maybe all our static data just gets mapped into address 0, which is what currently happens. Maybe we should ask, maybe this should be a method, get static. Oh, actually no, wait, we give it back. We give it back, don't we? Static offset. It's here. It's here. We have a variable for this. I forgot. Okay, so the address is wherever in memory this static data goes. Awesome. So, does this work? No, because we haven't made get entry point yet. So we need a function called get entry point. Get static, by the way, always returns 0 as the offset, which is great. That's really, really cool. And it's cool because I'm going to give back a U32 as the entry point because this is an address in AVM. Always going back 0 here is cool because in the future this might change as long as we're respectful of this, API shape. Anytime in the future we decide that this can be placed somewhere else, it'll work. But for now, we've got a sensible default that's going to flow through everywhere in our program. Hopefully we can be sensible about how this is consumed. So, get entry point. Go. Get entry point. If you see me looking over my shoulder, it's because I've got a mouse in the kitchen and I'm just like keeping my eye out in case he's rummaging around. I can hear him. He has been relentless in my kitchen. He's also eaten the food out of 3 of my traps without setting any of them off. He's one of those clever mice that's really hard to catch. So if I'm looking behind me, it's because I can hear a mouse. Which is great, right? I love it. This is one of my favorite things about being an adult. Okay, so we need to know the entry point. And the entry point is just where the static data ends, because that's where we start putting in our code, right? I guess I could also say, like, whatever the first function place is, like whichever block has the lowest address, that's going to be our entry point. That would also be valid. I kind of like that because I feel like it reduces duplicating calculations. So let's do this. In fact, let's go even smarter. Let's grab the function called main. That's our entry point, right? Or I guess, technically it might be called init or start or something eventually, but let's grab the function called main. Let's say self functions get main. If we don't have a main function, maybe this should be an option, right? I think let's grab our docs just to be sure. I love that I can just get the docs. Oh my gosh. For some reason, my Firefox instance was in every single scene of my tiling window manager. All right. Pet him. No, I'm not gonna pet the mouse. I don't know. I don't get this Dima reference. What type? State machines. Door open. This is cool. Yeah, this does make sense as well, especially from someone who's built a lot of random small games. Like having these kind of state transitions enforced in that linear way. Linear makes sense. I find we won't send you a letter twice. Linear, we also don't forget to send it. I've seen it applied for database transactions, right? Where you have to commit your transaction. That's really cool. Pilha, superhero devs, love it. But yeah, Dev Ninja, welcome. Pilha, welcome. We are making progress. We're making some good progress. This is a blinding page. So hash map. I just want to double check my hash map APIs. I think get returns an option. Yep, awesome. So we're going to have a reference to a block, and then we want to look at this block, and we want to see. This is good too. This means our main function doesn't have to go first, right? We can put it anywhere. We can put it anywhere we like. This is really interesting, actually. Yeah, cool. So actually, this is a change. And we're gonna call this init instead, because we currently just have a freestanding block that gets called first, but we can wrap that inside of a function. It doesn't need to. We can. This is good. This is really good. This makes our binaries less dependent on the order things are compiled in. So we can actually just find a special function and go with that. And so let's look at how blocks are defined. Let's remember what this field is called. Block offset. Cool. Okay, this is good. Let's go back to bin leng, where we say get entry point, and I think this returns a result, so we'll okay, or if this is not something, we're going to have an error, and this error is going to say something like no function init. Sure, we'll go with that for now. This needs to be a toString, and then we're going to question mark it. So if I make this, what happens? It's going to yell at me about something, right? Get init, Functions. Functions, vec, string, block. What did it say? Slice, indices, functions. Oh, sorry, functions is a vec. I forgot functions is a vec. So let's do this instead. For k, name block in self.functions. If name is init, then we're just going to return some block.offset. There's a better way to do this using, like, you could do this in a more functional way. I'm just going to use a for loop. Otherwise, we just return none. Make b. I always forget to put the b in. Okay, we've just got to say iter, or we've got to like put a borrow here maybe, or maybe both. Yeah, string block is not an iterator. Iterator is not implemented for slice iter. Okay, I guess that borrow wasn't necessary. Or I did something silly. Unclosed delimiter. Oh dear, that's because I forgot to put this here. Excellent. We've got an unknown import, and again, this feels good. Use simple VM. Bin format, binary file. This should be okay. Yeah, excellent. We'll also pull in a section definition from this because we make them. Output not found in this scope. Now, this is also very important. We're gonna make a new vec8. We'll say let mut output. It's gonna be a vec of u8. And we're just gonna make a new empty vector. We're gonna dump a bunch of data into it, and we're gonna write it to standard out. Beautiful. Headphones might arrive today. What headphones are you getting? What's a good headphone in the year 2024? I am a bit out of date in my headphone game. I'm currently using some Jabra Evolve headphones that a previous workplace, like 2 workplaces ago, bought for me for like video calls and stuff. They're Bluetooth. They're pretty good. But I'm a speaker guy. I tend to avoid using headphones where I can because I'm really paranoid about damaging my ears. Expected U16 found U32. Yeah, that's a good point. The entry point actually has to be... We're just gonna as U16 for now. The entry point can only be in the 0 page for now because I think that is all that makes sense. And I'm also just gonna put this in a variable. It'll say entry point. And where is this? Yeah. The address of this is, oh, hold on. It's not the entry point though. It's res get code offset. And again, we can do this in a very similar way. We can say get code section start. Wait. It's also this. I'm going to do it this way. So the offset, if we look through each function, right, the block with the smallest offset should match this. That should be the first address we put anywhere. And I'm tempted to do that. Oh, also, Elemental Magic card game. Thank you very much for following. Sorry I missed that. Let's use get code section start for now. I think that's probably better. Code section start. But the idea of taking the min block offset probably is also valid as well, and possibly more flexible. Requires less duplicate calculation. Static offset as U16. Everything's a U16. Except for the things that are U32s. Everything's a U16 unless it's a U32. Beautiful. So that compiles and it should run and output something as well. Nice. Got Vivanco. Cheap. Important for me. Cover your whole ear. Yeah, definitely. Grando SR125s. That's a brand I know. I don't know Vivanco. Sindhu from China. Is that $3.50? Or is that... I never know. Like in Australia we do like dots for decimal places, but I think this is a decimal place comma. Yeah, $3.50. It looks really weird. Like what everyone, like if you're used to 3.50 and you see 3.50, it throws you. Like whatever one you're used to, it throws you. JBL Tune 520BT. Don't cover the whole ear. Yeah, definitely. JBL's pretty solid. They're not my favorite brand, but they're pretty solid. Yeah, this like drives me absolutely crazy. I don't know what number this is, right? Well, I do. I mean, this is 1000.00, but there are definitely times I've seen numbers in like German texts, and I don't know. It takes me a second to work out what they mean. Cool. So let's compile something, right? Do I have a good example program? Progs Fibonacci. Does this still compile? Probably not. Let me rewrite this real quick. Wait, no, hold on. I don't want a let me write Fibonacci. Why don't I have good example programs for this? Let me write Fibonacci. Let's just do it in test.code, I guess. IO out. We could also do this. We could also rig up an IO device. I don't know if this is very interesting. Let's write Fibonacci. So we'll have int main. Oh yeah, I made another change that I was gonna break this, but we're gonna write it anyway, and we'll work from there. Commas, dots as thousands. Yeah, annoyed you as a programmer. Used to writing 3.1 for on paper. Definitely. Underscore a separator, universal standard. Ship it. Pass int 3.14. Yeah. I decimal place, decimal place superiority. I'm pro decimal place, pro dot decimal place rather. It's weird. Like I literally just call that the decimal place character because in my brain dot and decimal place are completely interchangeable. And I think you'd find the same with anyone in Australia. We will just call it that. Like a dot is interchangeably called a decimal. Okay, so. Fib, we're gonna take the number and fib n if n is less than, what is it? If n is less than 1, if n is less than 2, we return 1. Otherwise, we return fib n minus 1 plus fib n minus 2. This is Fibonacci numbers, right? 1, 1, 2, 3, 5, 8, 13, etc., right? That feels good. And then let's return fib 10. Let's work out the 10th Fibonacci number. That else block can be removed. It can. But I don't know. Yeah, okay, I'll do it. I'll get rid of it. I tend to prefer to write more if and else when it's my own language. I can hear this. The mouse is creeping. I can hear it. I was gonna move my camera so you guys could see the passage behind me and I could have chat on mouse watch. So that would be like I would get YouTube comments with the timestamps of the mouse. Mice are awful. I don't know like if people are from parts of the world where mice are from. But in Australia they're a really, really bad pest. They're absolutely awful. Okay, cool. This is what I wanted to see. This is the bug I wanted to see. Call the mouse Jerry so Tom can hunt Jerry. I've never heard that one before. That's actually pretty good. I'll pay that. So this is the error we wanted to see. This is exciting. No function init. And why isn't there a function init? Because I didn't put a function init in. If I look at my top level code gen, right? When I compile, the first thing I do, I have this block called load init where I put all of this initialization code somewhere. Now, this initialization code, I can actually turn this into a function now, a function called init. I don't need it to be this anymore. One of the hard things is, and I probably still need to do it like this is, as I do things like globals that can be initialized, inline. So for example, it's probably easier to demonstrate this. If I have a global right now, I say global int foo, right? I have to go into main and say foo equals 1, 2, 3. I can't say equals 1, 2, 3 here because when you're generating this code, like there's nowhere for that code to live. That code has to go into the kind of global context initializer, the preamble to calling main. So we can do that. We have an init function that does this. init it in main. Exactly, right? That's been my approach, because my approach has been to do the dumbest, simplest thing possible and fail forward from there. But having it be automatic has benefits, right? There's definitely value to having static initialization happen. So this idea that we kind of have to register all of our setup code is kind of valuable. It is kind of valuable. The problem is that we would need it to come before this, right? They would need to kind of be a stack, and they would need to get like if we add more initialization code, you'd have to treat it like a stack. You'd have to pop them off, and you would have to hope that, again, let's look at what can break here. Foo equals 1, 2, 3, global int bar equals foo, right? You better hope your initializer for foo comes before bar, otherwise bar won't be right, okay? What if it's like this? What should bar be initialized to? I don't know. That feels pretty runtime dependent, right? That feels like the kind of thing where you could get different behavior depending on how you compile it. But we need to think about this. So maybe this needs to be left on the floor for now, because answering it requires some kind of weird like graph dependency analysis. Unresolved symbol. Yeah, like they would have to be defined in order. I'm nervous about that. So my language doesn't have like headers. It doesn't have forward declaring functions. So I would like to think that this kind of thing would be possible. Otherwise you might end up in weird situations where, like, I don't want order of things to ever matter, but I also don't want to, maybe I just have to deal with forward declaration. I don't know. Anyway, this is all kind of food for thought, and it's not really the point of what I'm getting at here. I can just basically make this block a function called init, and that's what I'm gonna do. So in context, when I say load init, actually, do you know what I can do? I can make this preamble. I can make this preamble part of an actual. I mean, I can actually write this, right? I can go into, for example, fib.code, and I can write an assembly function called init, and I can put this block of assembly, inline, right? I can take this out of the actual special case compiler nonsense. And that feels very, very compelling. I obviously need some kind of like import system to do this properly, right? This needs to be a block that's imported into every file or every compilation at some point. But that's kind of compelling, right? Writing it in the actual language rather than having it be a special case. Let's see what this looks like. We're loading... Oh, actually... Yeah, well, we can do this. We can say im... I think I'm allowed to reference symbols, so we'll say stack start, right? Whatever the start address of the stack is, then we want to say we'll say US for unshift. We shift left SP4. We call a stack instruction. We push the base pointer to the stack. We don't actually need to do this. This is like writing out oh no, we do. We need to do this because there has to be something on the stack there, because if there isn't, when we return from the function, it'll blow up. So this is setting up the stack for a function call, because ultimately we do return from main back into this init block. So we need to also push the program counter. Then we add 0. We set the base pointer. This is a set. We set the base pointer to the stack pointer. We move it. Then we set the program counter to main. And once we return from main, we load the system halt index, the system handler index, and then we call system handler. Beautiful. So I think this would compile, right? Yeah. No, not quite. Stack start US undefined. We're going to get rid of load init though. That's going in the bin. It's gone. It's gone. We're gonna have to think about an import system, but this is gone. Cool. Now, where the stack starts is also interesting, right? And maybe that is actually something that should be part of the binary as, I don't know, like how does the system, how do we decide where the stack should start? Data dependencies, yeah, this global stuff, data flow analysis, exactly. This is I know this is a solved problem, and it's definitely something I can read about. It's just a lot to bite off and chew in one go. So I'm trying to put it off for as long as I can. Let's define a symbol. I think I can just say define symbol in my context. Just define. Should probably be called define symbol. Define, we'll call it stack start US because it's the unshifted stack start, and this is going to be, was it 3FF? Is that what I said? So this is going to become 3FFO. That feels like a sensible number, maybe? I don't know. We'll find out. We'll find out really soon. If I build this, whoa, what's going on here? Expected a symbol. Yep, that's cool. So this is gone. I think this is gone. I think this is gone. Oh, I deleted too many things. I deleted too many things. I should actually read what's going on here. Stack up, unused, we can get rid of you. Oops. What's next? This needs to be a ref. What's next? Expected symbol, found symbol, because I didn't save. Beautiful, okay. This weird American number comes here. Yeah, excellent. Yeah, exactly. Stack start EU 100 dot thousand, right? Or 100.100. What number is this? No one knows. No one can identify this mysterious number. So this also errors. Unknown token start stack US. That's interesting. I should be able to resolve symbols. I'm pretty sure my inline function, inline assembly functions resolve symbols, because otherwise they're a bit useless, right? Fib.code stack start US. Hold on. So when it's literally in here, right? It's this block. Inline assembly. We run a preprocessor. Preprocessor default. Preprocessor default macros. Yeah, no, that's all good. That's all good though, because it should just find, yeah, if it starts with a thing. So what did it say? Unknown token. Where does unknown token come from? Processed line part, unresolved, unknown token, var name. Get variable, self.get variable. Did I not do this? Did I not? Resolve, line stir map. So maybe I didn't do the thing I needed to do, which is for each symbol in, it's called what? In CTX, perfect. We'll look at context. I think it's just dot symbols for v and CTX dot symbols. We want to define a variable in the preprocessor. Define user variable, I think, right? Probably. Define user variable. With this value. The value is a string. Let's try turning it into a string. Value goes to value degrees Fahrenheit. Excellent. Nice, nice. S. Okay, maybe it's just this. Expected stir found string. We can do with that as well. Oh, this expected stir found string. Except that's not going to be true anymore because I'm going to put a ref here. Cool, so what does this say now when I run it? Unknown token main. So we don't know that main exists. And that's because that is actually sensible because we compile this. Oh, that is annoying because these symbols, we only have these symbols when we actually compile the body of this function. So the answer for this, and this is really silly, is to make sure this comes last. But again, this is this problem of being order dependent, which I would like to avoid. Actually, no, okay, that's not true. It still can't find main. Main still does not exist. Define user variable. Because these variables, they're just strings, right? There's no concept of a number variable in my preprocessor, I don't think. PP. I wrote a Python version of this apparently, I forgot about that. Define user variable. It has, where are we? Process line, blah, 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 blah. It really needs its own special case preprocessor. That's the hard thing. Yeah, it just has a list of variables. So yeah, what I really want is for the instruction generated by the preprocessor to be allowed to contain that level of uncertainty. Process line. Process line part. No, but the processed lines, right? We get a list of process. Okay, hold on. This is better. This is better. So rather than resolving it like this, we actually don't do that. When we call resolve here, we get a list of lines that might have unresolved symbols in them. We can look them up. We can turn them into unresolved instructions, maybe? That's hard, but I think we can. I think we can. But we need to parse. Oh, it's more complicated. It's everything. This is a rabbit hole that gets more and more complicated. Can I turn these into, because I have an abstraction called unresolved instruction, and the whole point of an unresolved instruction is it doesn't, you have symbols that are done, that are all linked together at the absolute last stage of compilation. So can I, for each line, oh, instead of mapping it like this, which is resolve first, reprocess line, where I take the parts of the line it's a line. If it's unresolved, var name pre-post. If there's something unresolved in it, I want to turn it into a unresolved instruction. Let's see if we can write the jankiest version of this possible for now. Codegen util. Okay. We're gonna try and do this. I feel it would be good. You feel bad? You remember when the US was created, but not Canada? Yeah, American cultural hegemony. Hegemony. I always get those letters mixed up. When was Canada created? I'm always shocked by how recently Melbourne was founded. It's a pretty recent city. I think it was actually founded after Adelaide, right? Like it's a pretty recent part of Australian history. It's like late 1800s, mid 1800s, I guess. It grew very quickly. It's a weird old place, Melbourne. Okay, so we're gonna make a function. We're gonna call it preprocessor to unresolved. This is a bad name, but it's okay. And this is actually going to be a static thing. It's not going to depend on any state. It's not going to depend on any state. Canada confederated in 1867. Australia became the Australia's federation, where we decided we were no longer a British territory, was in 1911. I'm pretty sure. So yeah, it's a kind of similar era, a little bit later. An preprocessor to unresolved instruction. We want to take a processed line. So P. We're going to take a processed line from the preprocessor, and we're going to give back an unresolved instruction. Cool. So we're going to match on this. If it is match p dot line. If it's a let's get rid of this prefix. If it's a processed line part, if it's a full line, then we just want to parse as instruction, wrap it up and return it like that. If it's got an unresolved part, there's only a few instructions we support having that uncertainty for, so it's actually not going to be too hard. Part unresolved. We have a var name. Oh, and the stuff that comes before and the stuff that comes after. That's right. So, oh, that's a really annoying way of representing it, though. That's a really annoying way of representing it. Pre-post. Yeah. This just turns it into a string. All we care about there is a string. And it's this recursive thing. So we want to collect it into... crap. Realistically, we only want one unresolved thing per instruction. The way our unresolved instructions work, they can only support one unresolved thing. So our unresolved instructions look like this, right? Unresolved instruction. It's either a full instruction, or it's an immediate with a symbol, it's an add immediate with a symbol, it's an add immediate signed with a symbol, or it's a label with a symbol. So let's work out what instruction we're dealing with. Yeah, wow, okay. So much later than... Yeah, it's kind of funny. I don't know. Squeaky wheel, something like that. If you don't have a reason to do it, then why bother? Because it's a big deal. I mean, even in Australia, we had a referendum, I think in 1996, about becoming a republic, because Australia still has a ceremonial figurehead called the Governor-General, who reports to the Queen, and the Governor-General appoints the Prime Minister, or something like that, right? Basically, they're part of this like old ceremonial process, and we were gonna... Well, you know, there was a political movement to become a republic and do away with the Governor-General, and I kind of like having this figure who was appointed by the Queen, who kind of aren't, or the King, I guess, you know, don't have a Queen anymore. Canada has a Governor-General too, yeah, it's just some weird old colonial stuff, you know, but also having your own president has its own problems. There was one time when an Australian Governor-General gave a Prime Minister the sack, seemingly for very controversial reasons, and that created a bit of a constitutional panic in Australia. I think that was back in like the 70s, 80s. But other than that, they're usually pretty chill. It's just like a cushy diplomat role, you know? Good job for your mates. So, we can do this. This is an unresolved instruction. This needs to be a result. This has to be a result, because it can blow up in a whole host of ways. We're going to result unit for now, but we're going to probably... Actually, no, let's make this a compiler error. Yeah, yeah, hold on. Who was it? It's... The guy's name's Kerr. 1975. Dismissal of Prime Minister Gough Whitlam from the ALP by Sir John Kerr. I think the CIA or someone called him Airman Kerr. It's super, super controversial. Yeah, really interesting read. I'll put it in chat. What a time. What a time. Okay, so the most important thing in working out what kind of unresolved instruction we're dealing with is finding the leftmost thing, because that's always the name of the instruction. So we'll say let walk equal pre, because pre here is, if I look at my preprocessor, processed unresolved. Yeah, so it has itself on the left and the right. So while pre. So I want to loop through this until I find the leftmost thing. So let's maybe say reassemble. Let reassembled equal. Can I do that? Does that work? Process line. Can I turn it into a string? How does this do it? Reprocess line. Yeah, okay. But this tries to get it with a variable name. So I don't want it with a variable name. I just want the representation. I want this as like a thing that I can just print out. So if the left part is an unresolved thing, then I just need to do it recursively, and that's okay. That's okay. We just build up a list of variables to well, no. If the thing on the left-hand side of this is unresolved, that's a problem, because we're only allowed to have an unresolved thing in an unresolved instruction. Okay? That's how we do this. So basically, I've got an abstraction that was designed for something else, and I'm trying to shoehorn it into another abstraction. I've got a preprocessor that was built not with this compiler in mind, and I'm trying to shoehorn it into the idea of resolving this stuff later. This is a mess, but I think it's the right mess. I think it's a helpful and useful mess. This is still a side quest to getting strings working. I'm getting very, very sidetracked. Reassembled equals. No, let's match. Is this the wrong thing to do? Is this just the wrong... I'm having a real crisis that this is maybe just not the right direction to go in. Because I want a good mapping between these things, but I think the best solution would be to rebuild this to use an unresolved instruction, like the abstraction that my lang uses. Like, make these two things use the same abstraction, then there's no weird mapping step needed. The preprocessor has this resolve past 2 step where it does all of this. This is too big to tackle right now. This is actually too big to tackle right now. This needs to be done properly. And I need to not turn them all into Ds. That's also not good. That was a fun thing to think about, but it's just too much. To do. We're going to put a to do in. We're going to say to do. Use. Actually, we'll put it here. Unresolved instruction. Wait, did I type meth? Did I what? Am I making typos? Am I not noticing? Add it to my roadmap. Yeah, I mean the roadmap is long and completely up here, but it is a long path. Okay, so in conclusion, I'm not quite here yet. Oh, the turn everything into a D typo. Yeah, I guess I did. What is that? I highlighted and then I pressed like SD or something. Suggest I write a roadmap. Look, it's a good idea. It's on my list of things to do. I've enjoyed being loosey-goosey with the development of this language, but it's hitting a point where I can't necessarily continue to do that. I think, hello? I think my keyboard's dead. What's going on? Okay, there we go. That was weird. Yeah, I couldn't focus on that window for some reason. So let's go back to top level and just like undo some stuff real quick. Right, we're gonna get this back. But now in our context, we do this a load of net, self and net. Okay, so now when we do this, instead of doing it like this, we're gonna make a block and call it init and make it a function. Okay, so, and this doesn't support multiple static initialization blocks anyway, so that's cool, that's cool. So let's make a block. The default block, right? Cool, and we're gonna set the instructions. Wait. Except we can't do that yet. We need to set it here, and then in the top level, when we do all of our function placing, for each function. Oh no, we do it here. We add it to the functions. The offset's only set. This offset doesn't actually matter anymore. That's okay. Okay, so I'm right. Let block equal block default. I should probably initialize it smarter than this. I should probably use an actual initializer with fields. Instructions is easy. This is just our program. The offset we don't care about, we don't set. The local count is 0. The local offset 0 and the args is empty vec. Perfect. Args empty vec, and then offset we'll just say is 1. Because that's going to get redone anyway. And now we say self functions push, and we're going to push, and now I think functions string block. So we want init. Let's try this. We might have to toString it. We'll see what we go. Init and then the block. Make B. What's it going to yell at me for? Add a semicolon. Yep, that checks out. Cool, this has to be toStringed. Nice. Okay, so what happens if I build this now? Nice, that looks good. It has taken over. Let's XXD it. Cool. That looks like it might be too much static data, but as long as our offsets are right, this should all be okay. This looks like a little bit too much padding. Let's see what happens if I run it. Let's pipe it into cargo R VM. Okay, we get an invalid instruction. That's okay. I don't think we set the program counter right. Bin VM entry point. Set PC entry point. Bin lang. Are we setting the entry point correctly? You're looking at basis. Yeah, cool. Creating a parse state struct the whole thing. Parser generators parser combinators? Parser generators. But yeah, I'm using parser combinators that I've written myself, and I can now see the benefits of recursive descent. But it's fun. It's been a fun journey. There's a lot I want to clean up with my parser combinators to make the arrows nicer, and I think I can do it. I think I can buck the trend. I might have to go, actually. Holy crap, I didn't realize how late it was getting. Cool, alright. I'm probably gonna have to leave it there. That's unfortunate. Let me like spend one more second and see if I can fix this thing. Entry point, get entry point. Oh, hold on. So let me do this other thing. Bin dump. Entry point 1, that's wrong. That's wrong. Why is this 1? Why does this have... Okay, I'm gonna do some debug printing because I think that's gonna help. I'm gonna say offsets. Define. Just gonna do this real quick. Okay, and we're gonna see what it says. Init equals 0. Well, that's not right. That's really not right. Program offset. Oh no, but I guess it is right. That does make sense, doesn't it? Right? Because the program offset get code section start, well, there's no static, so the code's going to start at 0. So init is going to go there. And then main after that, and then, This is cool though. I like that init is now actually a function that gets placed as a function, or like a block that gets located as a function. It's less of a special case. That feels nice. So why then do we say the entry point's 1? Let's look at context. Get entry point. Block offset. So why does it, if this is defined as 0, why is the offset 1? Oh, the offset's 1 because we never actually set the offset, right? That's funny. That's really funny. We actually want to get the symbol in it, not this block. We don't care about it as a function definition. We care about it as a symbol. So let's actually self.symbols get init. Okay, or oh no, wait, not even that. We just question mark it. And that's it. That's what we do. That's even easier. Cool. How do I do this? How do I deal with this? Okay, surely someone has a good answer for this. What do I do in this case? Do I just have to map? Oh, hold on. Sorry. My faith in the Rust compiler is too low. It literally told me. I've struggled with this a few times. Apparently I've just never read the error message far enough. Okay, so let's see what it says now. Nice, that looks good. Let's pipe that, well actually hold on, let's get rid of my little println. Let's pipe that into bin dump. That looks cool. Let's pipe it into the VM instead and see what happens. And invalid instruction. Section size, this is fine. Address 0. I wonder if this breaks it somehow. It's saying that we should dump offset 46. 46? 46. This isn't hex, is it? So this is just 46. What's 46? Hold on, I want to XXD this. 46. 46 is 2E, so 2... Okay, so we're off by like hex 50. What's this? CD, yeah. We're off by like almost hex 50. Can even do cargo fix. Yeah, cargo fix is cool. Cargo fix is cool. All right. So what the hell's going on here? What is... Why is it putting so much padding? Why is this so padded? Why is this header so big? What are we doing? What are we doing wrong? Bin length? Like, we only write... This is our output, right? The only thing we write is this binary. We put the data in. The header should only be... (46). 46 is 2E, so why does all this stuff get written like way out here? Unless I'm putting this padding in somehow. Am I padding the start of this? I am. I'm probably padding the start of it with some like weird get instructions. Yeah, get rid of this. Get rid of this. That's not relevant anymore. Self.ins. Self.init. Okay, let's try again. Let's try again. That still's wrong. That's okay. Don't panic. This FF concerns me as well. 2E 02 01 00. This is the entry point, I think. I'm gonna have to leave it there broken, unfortunately, but we can deal with this. We can mush this down, right? This is mushable. We just need to move all this. I don't know why there's an FF, but we need to mush everything starting here up to here. There's just a bunch of zeros in the way. We can work out what this data is. We can find that, and then it'll run and it'll be perfect. So thank you very much for tuning in. We're going to quickly find someone to raid. Let's look at my goals. Did I do it? Not really. Not really. Let's give this like a not really. Didn't really achieve much. But we're making progress, and progress is good. Quick raid. Who is someone good that we can throw some wonderful viewers over to? Who is online? Togglebit's online. Togglebit has a few too many viewers. I don't want to throw a measly 7 or like 9 viewers over to Togglebit. ASMR programming, that looks cool. Playtest, bit of French. Loving my French devs lately. Love rating people who don't speak English and then making them work out who we are. Please suggest someone for me to throw some viewers onto. Who looks good? Anyone cool on right now? Thank you, Bovius. I love it. Fishing game. Let's try. There's a duck person. Let's see what this fishing game's like. Throw some people over here. So, thank you so much for tuning in. Let's go check out some more awesome developers. Throw some people over that way. Throw some love over that way. Thank you so much. Thank you everyone who's been watching on YouTube as well. Love you all. And I will be back very, very soon. Bye.